All right, this is the second part of solving all equations. This time we're going to be looking at exponential equations, logarithmic equations, and rational equations. Exponential equations are ones where there's a variable in the exponent. The first step of these is to get the exponential portion by itself. The reason we need to do this is we can't multiply before doing exponents because of PEMDAS. So we need to get rid of anything else that's there. So in this case, the exponential is getting multiplied by 8, so we divide by 8 on both sides. And multiplying 8 and dividing by 8 cancel each other out, they're inverses. So we get 3 to the 7r plus 10 equals 8 divided by 8 is 1. The next step, to undo an exponential, we need to do the inverse of exponential, which is a log with the same base. So in this case, because it's 3 to the power of something, we will do log base 3 on both sides. Let's remember why this works. This is saying 3 to what power gets us 3 to this power? And the answer is just going to be whatever the exponent is. 3 to this exponent will get us 3 to that exponent. And so these cancel out, and we get 7r plus 10 equals, this is saying 3 to what power gets us 1? 3 to the 0th power gets us 1. And from here we've just got a linear equation. I'm going to subtract 10 on both sides. So 7r equals negative 10, and divide by 7. Okay. I'm going to do one more exponential equation because in the exponents and logs mastery, the part right at the end got cut off, and I want to make sure I address that. Again, we have an exponential. We're going to subtract 8 on both sides. This is an exponential involving e, which is the most common type of exponential we have in calculus. And to cancel out e to the power of something, we need to do a log with a base of e. We don't write log with base e, we write natural log, ln. So we're doing the natural log, logarithmo natural, on both sides. The natural log on both sides. So this is saying e to what power gets you e to the x minus 7. So that cancels out and gets us x minus 7. On this side, this is saying e to what power gets us 8. Remember, e is 2.7 or so. And there isn't a whole number power that we can raise 2.7 to get natural log of 8. And so this is simplified. We just leave it as natural log of 8. The last step is we add 7 to both sides, and we want to make sure it's clear that the 7 is not inside of the natural log. And so you'll notice that up above, I didn't put parentheses because it has to be natural log of something. So this isn't like natural log times 8. That doesn't make any sense. It has to have something in it. But if I had written natural log of 8 plus 7, maybe you're thinking, well, you should add the 8 plus the 7 first and then do the natural log of 15. But that's not what's happening. We're doing the natural log of 8 and then adding 7. Another way we could have written this that would have been good is we could just put the 7 plus natural log of 8, and then it's clear that only the 8 is in the natural log. This is probably a little bit better. But both of these are correct. Either way is fine. Okay. Logarithmic equations. The way we solve a logarithmic equation is we get the log by itself first. So we're going to get the log by itself. We're going to add 7, and we're also going to, well, I'll do it one step at a time. Fine. Negative 7, log base 5, p plus 1 equals negative 21. We're going to divide both sides by negative 7 to get the log by itself. 3, a negative divided by a negative is a positive. And now to undo a log, we're going to do an exponential. We're going to do 5 to the power of both sides. Notice we're not doing 3 to the 5th power. We're doing 5 to the power of 3. That's important, that order. And so we get p plus 1 equals 5 to the 3rd power, means 5 times 5 times 5, which is 125. So p is 124. All right, our last type of equation is a rational equation, where there are variables in the denominator. When there are variables in the denominator, we want to multiply by those denominators to cancel them out. So we're going to multiply both sides by b squared minus 4b to cancel out dividing by b squared minus 4b. That'll cancel out these two. But the question is, do we also need to multiply both sides by b to cancel out the dividing by b? Whatever you do to one side, you have to do to both sides. So we might also need to multiply by b. But before we do that, there's a trick we can do, which is we can factor the b squared minus 4b. It's b times b minus 4. And what you'll notice is there's a factor of b here. And so that will cancel out with the multiplying by b, will cancel out with the dividing by b. So multiplying by b squared minus 4b is the same as multiplying by b times b minus 4, and that will cancel the other denominator anyway. So we don't need to multiply by a separate b because this is multiplying by b, just in a different form. So let's look at how this works. Multiplying and dividing cancel each other out, and so we end up with b plus 6 equals multiplying and dividing cancel each other out, so we end up with 1. And here I'm going to use, we're multiplying by this and dividing by this, but I'm going to use this other form because we can see that it's multiplying by b and dividing by b, so that will cancel this portion out. There's still a plus 5 times b minus 4. Make sure you pay attention to this sign. Sometimes it's a negative and that messes things up, but positive 5 times b minus 4 is 5b minus 20. Now it's a linear equation, and we can solve this easily by getting the variables on one side and the constants on the other side. So when I move the b to this side, we get 4b, subtract b, and then I can either combine and move or move each one separately. Either way, we end up getting 25, oops, is it 25? Yeah, 25 equals 4b, so b is 25 fourths. Hopefully that is helpful. We do need to check at the end to make sure that this doesn't make the denominators 0. If it makes the denominators 0, it's an extraneous solution, but in this case, it does not make any of the denominators 0, so it works.